Next up, we have Professor Hector Geffner. He is Alexander from Humboldt professor at RWTH Aachen University, where he leads the chair of machine learning and reasoning. And in addition to that, he is a guest professor at Linköping University in Sweden. And today he's going to talk about deep learning and shallow understanding. The floor is yours.
Thank you. Okay, so glad to be here. So this is going to be a bit different. I actually try to talk about AI research, okay, because this is what I do. So it's an academic talk from somebody from the university. And as the title suggests, one of the things that we're interested in is about learning and reasoning, in particular about the interface. Okay, as you know, so all these deep learning systems, okay, that became so important these days. So the question is how much they understand, okay, or how to make them understand to make them a bit more reliable. So I'll talk a little bit, so don't get intimidated by slides with some notation that is not completely clear. So, so basically in the last decade, there has been a revolution in AI and a true revolution in also the applications of AI. And one way to understand deep learning is that also deep reinforcement learning is that basically you're computing functions, okay? So functions are these boxes that map inputs to outputs. So you can map an image into the bounding boxes of the objects. You can map the configuration of the chessboard, okay, into a probability distribution of the actions, okay, or the possible moves to do. Or you can have text in the input and generate new text in the output, and so on. So from a mathematical from the point of view of computer science, we talk about functions. And these functions have a characteristic. Normally, the structure of the function is fixed. And what you learn are the parameters of this function. It's a very simple idea, a very simple approach. Actually, say that the ideas have been around for some time, mainly since the 80s and so on. But basically, these days we have more data, more compute, and a very interesting and original range of applications that are actually making a big difference. That's what we are here. So definitely a true revolution, okay, in AI. Even though AI has a longer history, okay, than the last 10 years, and I would say that it is still unfolding, okay, so we have not seen all the results and so on. It doesn't mean that an artificial intelligence, okay, a human-level intelligence is something around the corner and nothing of the sort, even though the impression sometimes that one might get by interacting with ChatGPT or this type of systems is that they seem to be incredibly smart and so on. So from the point of view of applications, one of the key things is that they are not transparent, so you cannot understand exactly what they do and how they do it. They're not reliable, okay? So you do not want to use deep learning systems in applications that involve some sort of risk. And that's the reason, so they're not trustworthy, okay? And one reason for this is they do not try to make sense of what's out there, okay? So basically they are programs that are generated from the data, learned from the data, and also limited in a sense, okay, from the sort of representation and abstractions, okay, that they can build from the data. Okay, in AI, there has been another approach, okay, for many years as well, that is not as well known, okay, these days, because it doesn't lend itself so easily to applications, okay? There's plenty of data, and these are the so-called model-based reasoners, okay? The word that people in AI use to refer to them is solvers. Also, these are functions, okay, these little boxes that maps inputs into outputs, okay, but the nature of the inputs and the outputs is different, okay? So you may have some logical problem in the input and get, in some sense, some sort of answer, whether sort of a formula follows from the other formulas or not, okay? You can have a planning problem and to get into output a plan. You can have in a probabilistic network, okay, the so-called Bayesian networks in the input, and then in the output you can get answer to queries about what is the probability that something, okay, will happen given these observations hallucinations that I've managed to get, and so on. So in all these cases, you do reasoning, in some sense, going from inputs to output. In this case, it's not. It's basically out of the box, okay? So you don't have to do a process of slow training, okay? You have to do thinking from going from the input to the output by exploiting, in some sense, the nature of the models. There are many expressive models. And also, type of reasoning that you can do these days is extremely broad and effective, and even there is a way where you can understand that deep learning systems actually are trying to solve some optimization problems, so they can be understood, okay, as some solvers of some type. Now, while in the case of deep learning approaches, okay, so one of the limitations is that they do not understand what's outside, that they cannot reason, and so on. The limitations of these systems is that they depend on models, okay, that have been crafted from data. And to have a model, in some sense, you really need to understand the problem, okay? Well, in order to use data, you just use the data. Somebody has to construct the models, these optimization models, or planning models, or probabilistic models, okay? Normally, they are constructed, okay, by hand. So, in a way, this brings me up into a topic that was mentioned in the previous talk, okay, by Michael. Okay, so the same name appears again, Daniel Kahneman. Okay, so Nobel Prize, even though we mentioned it related to AI, it's actually Nobel Prize in economics, even though he is actually a psychologist, okay, by training. So, he is in some sense one of the fathers of what is called behavioral economics. So this is a very interesting book. And basically the idea of this system 1 and system 2 that in the previous talk was mentioned, I'll mention it again because it's a very good metaphor of what is the state of the art in AI. In some sense, what Michael was talking about, the system 1, the so-called intuitive, okay, reflexive mind, okay, so you get inputs, you get outputs, don't have to think about them, okay, so they're fast, associative, does not take any effort, okay? So this is what is normally called system 1. These are related to the sort of boxes, okay, that you get out of learners, okay? Not particularly flexible, and so on. On the other hand, okay, system 2, that does reasoning, okay, these days I say this sort of activity that is getting out of fashion these days, okay, but somebody has to do it, okay, the thinking. So this takes effort, okay, takes some education, effort, so you have to pay attention, okay, to what you're doing, so you cannot do in parallel, you use the memory, okay, that you have, and so on. And in some sense, this is related to what solvers do. Okay, what was one of the biggest difference between sort of this dual account of the human mind and this dual account of the state of artificial intelligence research? So the main difference is that in the case of the human mind, these systems are continuously talking to each other. Okay, while in the case of AI, okay, these two threads, okay, in AI research are so far not very well connected. So how do they talk to each other? So one instance of this, actually I'm going to come back to this in a second, is when you learn to drive, okay, learn to drive a car. Initially, okay, it's very much a system 2 activity. You have to pay attention to so many signals, you have to pay attention to everything, what action to do, okay, you have to turn the wheel, and so on. As you become more proficient, okay, basically it begins being an automatic activity. You can drive while you're having a conversation. You can drive while you are thinking about something completely different. However, okay, that's the way that the human way works. In certain type of maneuver, you stop, okay, the conversation and you focus on the driver. You have to park in a tight space, so you stop the conversation and you focus. You have to overtake a car in a narrow freeway, okay, that's the same thing that you do. And this sort of thing, in some sense, is completely absent these days in AI. You have systems, okay, that do relatively very good learning, systems that actually can do very good reasoning given the right representations, but you don't have this back and forth interaction, okay, that we have in the case of AI. So to a large extent, I will say that one of the main challenges, okay, from the point of research in artificial intelligence is how to bring these two threads together, okay? Or as it's called, system one and system two intelligence, or if you want to call it, how to get deep learning and reasoning, okay, interacting with each other. And of course, okay, one way to go about this is that in deep learning, you learn the representations that will support reasoning. But this is actually not happening right now. I'll talk about that in a second. So without having this integration, okay, it's not possible to have truly reliable AI systems, okay? And one example of that, okay, that appears, okay, once in a while in the newspapers and so on, is self-driving cars, okay? So self-driving cars have attracted huge levels of investment, okay, for many, many years. Why don't we have self-driving cars in our streets, except in certain parts of Arizona, maybe in some other places? Why is that the case? And the reason is that the system has been trained as a black box, okay, from data that cannot make sense of the world. Is too risky to be deployed, okay? So if a human driver, okay, suddenly sees that a child is getting near the freeway, okay, is chasing a balloon, in some sense you can use your common sense, okay, to predict, okay, some of the possibilities, and then, okay, to stop the car. On the other hand, systems that depend solely on data, if the data has not reflected, okay, does not contain sufficient information about this type of situations, okay, the guy will not know exactly what to do. So it's very important, not only in some sense to have systems that are based on data, but systems that can understand the environments, okay, where they're going to be deployed as well. By the way, so little example that I actually borrowed from Daniel Kahneman. So Daniel Kahneman is known because of his book as a Nobel Prize, but he has been doing this sort of things, okay, many years ago. And actually, I forgot to mention, so the person who actually coined the name System 1 and System 2 is not Daniel Kahneman, is Kitsanovich, okay, another psychologist that is worth looking at. So if you really like the book The Selfish Gene by Richard Dawkins, and you like the book by Daniel Kahneman, you definitely have to take a look at this book from 2005, okay, because it's called The Robot's Rebellion, and basically he's talking that the tool for liberation, okay, from the program of our masters in our genes, it's basically System 2. So it's an interesting take on these problems, okay. So, but one example that he gives that I think is very intuitive. So I tell you a problem. A bat and a ball together cost 1 and 10 euros, okay? I tell you that the bat costs 1 euro more than the ball. How much does the bat and the ball cost? Okay, so normally I have to say we are pretty lazy, okay, when it's thinking, okay, even those that live out of that, and we are supposed to teach that. So when you see like this, so immediately System 1 will trigger and will give you an answer, okay? 1 and 10 cents. Actually, 1 and 10 cents, they add to this and so on. But if you have a well-trained System 2, it should check the answer. This answer is not good. It does not comply with these constraints. In particular, 1 is not more than 1 euro more than the ball. Okay, so you know that this is not going to be the answer, and then you have to go back to think again, and maybe tell the System 1, give me another answer. That's 1 is not good. If you don't have this sort of control, okay, things are not so good, and these are the sort of things that are happening these days with AI systems. So the point is that all these reactive answers, okay, will not work too well. So this brings us to another question is, okay, so does systems like ChatGPT, do they exhibit reasoning skills? Actually, there are many papers published on that, even things, okay, that you see in the newspapers and so on. So the question is, I mean, does ChatGPT 4 reasons or not? And the question is, it exhibits some level of understanding, some level of reasoning, but of course, it's not systematic and it is not reliable, okay? So, and another question that is very much related, is it the case that ChatGPT 4 does not reason systematically because it's not possible to reason systematically, let's say in logic, with neural networks? No, actually, that's not the case, okay? There are deep learning systems that reason very, very well. actually, two examples of that. One is specialized, okay? All these systems, okay, AlphaGo, AlphaZero, and so on, when they play chess, they play much better if they do not play reactively, okay? So before each move, they do some look ahead as actual players do, okay? So in some sense, but this is thinking specialized for that particular setting. However, there are even some very interesting relation between certain type of neural networks called graph neural networks and what is called predicate logic, okay, so a very expressive logic that basically the GNNs can do everything that you can do in the fragment of this logic when you have two variables only. I know this is a technical thing, but it's basically saying that you can do very well-defined reasoning, okay, that is not trivial at all, can be done. But the reason that ChatGPT does not do this sort of reasoning is because it's not learning the representations that will allow to perform this sort of reasoning. So one of the main topics of research right now is how to make these systems, these deep learning systems, okay, enhance them with reasoning capabilities. And of course, there is a whole school and a whole thread, okay, trying to add more data, playing with the biases and the architectures of the net, okay, so that you get this emergent behavior. And on the other hand, there is another sort of top-down view where the point is you want these networks to learn the right representations that that support reasoning, okay? So in some sense, you learn representations that have some semantics, because in semantics, the notion that underlies the capability of reasoning, okay? So I would say that the first approach is precisely what's the mainstream approach was in machine learning. So in Aachen, sort of, normally we are sort of engaged with this second approach. Okay, so getting close to my finishing, okay, so just a few last words about the social impact of AI, okay, taking a position about some of these things. So even though human-level intelligence is not around the corner, AI as it is now still can be used for good or for ill. So a lot of talk about ethical committees and things. So a lot of this is public relations. So it's definitely not, it's good, but it's not sufficient. So regulation is needed, politics is needed, value alignment is needed, but not just of AI, okay? So there are many other things have to be aligned, okay? So that technology, okay, will play, okay, for societies, okay, and not just for the economy or some of the people, okay, so managing the economy. As normally we talk about the benefits of technology, okay, so the benefits of technology do not trickle down automatically, okay, to everyone else. I would say that the harms sometimes trickle down more easily. And actually, there's a very nice, very recent book that is actually focused on this topic by two very mainstream economists from MIT called Power and Progress, Our 1,000-Year Struggle Over Technology and Prosperity. And that's precisely the point. In some sense, okay, that the issue of how to make technology, okay, serve societies, okay, there is a political struggle, okay, going on, even if you go back to the Industrial Revolution and many other periods as well. So to conclude, so I would say if you want good AI, so definitely we need a good and decent society. We're not going to have that otherwise, okay, with intentions and so on. And since I love to talk about system two, so basically it has to be a society, okay, that gives a prominent role and encourage system two and facts, reason, and the common good, okay? And I'll finish there, okay? Thank you.